In this video, we'll look at matrices, how to solve for determinant and the inverse. And the question is coming from 2025 paper 2 internal grade 12. Here is the question. Given that matrix L is equal to -2, -2, 6, 7, and matrix M is equal to x, -4, -3, 2. Find the value of x for which the determinant of matrices L and M are equal. Inverse of matrix L. So we're going to look at how we can solve in this scenario where we are given that for the two matrices the determinant is equal and you have to solve for x. Let's now look at the solution. In the first question, we are told to find the value of x, given that the determinant of matrix L and M are equal. So what you have to know is that to find the determinant, you have to multiply the major diagonal, then you subtract by product from minor diagonal. So like for L, the major diagonal we have is -2 and it's -2 and the 7 here. This is the major diagonal, and then the minor diagonal is this one. Okay, so in this case we find the determinant of L. After finding the determinant of L, we can easily find the x since the determinants are equal. So we will multiply what is in the major diagonal, which is -2. Okay, -2 multiplied by 7, right, like that, minus what is in the minor diagonal. In the diagonal you have -2, and it will be multiplied by 6. Multiply -2 multiplied by 7, you are getting -14. Then -2 multiplied by 6, that is -12. So the negative, we have another negative here. We are going to have a positive here. So we have +12. Then when you do the math, you have -14 plus 12, you get -2 as our determinant. Having found our determinant, we can easily find the value of x by multiplying what is in the major diagonal, of M minus what is in the minor diagonal of M as well. Then it should be equal to the determinant. So in this case, we'll say, open brackets, in this case we'll say x multiplied by 2 minus the minor diagonal, -4. You have -4 multiplied by -3 multiplied by -3. Should be equal to -2. This is our determinant. So when you multiply the major diagonal minus the minor, it should be equal to the determinant of m, which is -2, since they are equal with L. X multiplied by 2, we are getting 2x. 2x. Then -4 multiplied by -3, that is 12. Say minus 12 equal to -2. Then let's collect the like terms. So leave 2x to the left side, and you say equal to -2, -2 plus 12. If we collect the like terms and find the additive inverse of -12, that is +12, which will be at the right side. Then you say 2x equal to, it will give us 10, which will be the positive here. Then you say over 2 over 2, and finally we have x. So 10 divided by 2, that is 5. So our value of x is in 5. Let's move on to the next. We find the inverse of matrix L. So to find the inverse, first of all, we have to find the determinant. After finding the determinant, like what we have done here, we have introduced the 1 on top of the determinant, which represents the inverse. So you say 1 over the determinant, which is -2. We are not replacing with the value of x, but with the determinant. Then in the matrix of L, matrix L, in the major diagonal, you swap the numbers. So here when you swap, we have 7 here. Then -2 will be here. What happens in the minor? In the minor, you change the signs. Here we had -2, it will be +2. Here at +6 become -6. Then you can multiply 1 over -2 with what is in the inside the brackets. As you are getting -1 over 2 here. Then when you multiply 1 over -2 multiplied by 2, we are getting -1. Then here when you multiply 1 over -2 multiplied by -6, you're getting 3. And here 1 times 1 over -2 multiplied by -2 there, we are going to have +1. So on the first one here, it will be -1 over 7. When you multiply, it will be 1 over 7, not 1 over 2. -1 over 7. Then you close the brackets. Okay, so this is how you find the determinant and calculate for the inverse of a matrix C under paper 2. Yeah. Thank you very much. Thank you for joining me in today's lesson, and make sure you subscribe for you to receive notifications every anytime I drop a new video.